Welcome. Okay, so we all get what 10 squared or 10 cubed means, right? You just multiply 10 by itself a couple of times. Simple. But what happens when exponents start to get a little weird? Today, we're putting on our detective hats and investigating a really cool mathematical mystery. I mean, think about it. How in the world can you multiply something by itself? 0 times. It doesn't really make sense, does it? It feels more like a philosophical question than a math problem. Your gut might tell you the answer should be 0, but spoiler alert, it's not.
And then you've got this guy, the negative exponent. Is this a negative number? Does it send everything into some kind of mathematical upside-down world? Well, that's what we're here for. We're on a mission to crack these cases wide open.
So our keys file is officially open. The central mystery is simple. How do we make any sense of these exponents that seem to break all the rules we thought we knew? Now, like any good detective, we're not just going to guess. We're going to start with the facts. And here's a little secret about math. The most powerful clues are always hiding in patterns. Our first one is hiding in plain sight, in a pattern you're already totally familiar with. To find this hidden structure, we're going to build ourselves a table of evidence, and we'll use a number we're all comfortable with. Good old powers of 10. Okay, take a look. This table looks pretty basic, but it's holding a crucial secret. Look closely. As the exponent in that first column drops by 1, from 4 to 3 to 2 to 1, what's happening to the actual value over in the last column? You see it, right? To get from 10,000 to 1,000, you divide by 10. From 1,000 to 100, you divide by 10. From 100 to 10, you divide by 10. It is a perfect, predictable, beautiful pattern. And this is our key. So if we trust the pattern, and in math, you always trust the pattern, what has to happen next? If we take just one more step down, from an exponent of 1 to an exponent of 0, what does the value have to be? This is it. This is our first major breakthrough in the case. We're literally about to solve the mystery of the 0 exponent, not with a fancy formula, but just by following the evidence we've already laid out. It's so simple. We just take the last value we knew for sure, which was 10, and we apply our pattern one more time. We divide by 10. And 10 divided by 10 is, well, 1. It has to be 1. The pattern forces our hand. There's just no other logical possibility. The logic is totally airtight. So we can say with 100% confidence that 10 to the power of 0 is 1. Case closed on that mystery. And you know what the best part is? This isn't just some weird party trick for the number 10. This logic works for any non-zero number you can think of. 5 to the power of 0 is 1. 87 to the power of 0 is 1. We've just uncovered a universal rule of mathematics. Okay, we've cracked the code for 0, but our investigation is not over yet. We still have that other suspect, the negative exponent, on the loose. So what do you think happens if we just keep this pattern going? What if we go even farther down the number line? We just keep doing the exact same thing. We start with our new value, 1, and we divide by 10 again. That gives us 1/10. Divide by 10 times again, and we get 1/100th. So wait a minute, negative exponents don't create negative numbers at all. They create smaller and smaller fractions. And this reveals another incredible connection. Look at this. 10 to the power of -2 is the exact same thing as 1 divided by 10 to the power of +2. That negative sign, it's just a little signal, an instruction, telling you to take the reciprocal, to flip the number into a fraction. And there it is, our second universal rule. This gives us a super clear, precise way to deal with any negative exponent we might run into. You just move the expression to the denominator of a fraction and make the exponent positive. That's it. And just to be absolutely sure we didn't get lucky, let's check our work with a different number, like 3. For powers of 3, as the exponent goes down by 1, we divide the value by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. Look at that. The pattern holds perfectly. Our theory is confirmed. So, after a little detective work, we have officially solved the case. The whole mystery of 0 and negative exponents has just vanished. And in its place, we're left with 2 clear, powerful, and totally predictable rules. So, these are the 2 big takeaways from our investigation. If you can remember these, you've cracked the code. What used to be a mystery is now a tool in your mathematical toolkit.
And there you have it, summarized perfectly. What started out as a really confusing puzzle is now a clear, logical principle. It's not magic, it's just the beautiful result of following a simple pattern to its natural conclusion.
And that's our explainer. We've successfully closed the case of the integer exponents. But, as is always the way in the world of math, solving one mystery just opens the door to an even more interesting one waiting right around the corner. What do you think a fractional exponent could possibly mean? We'll have to save that investigation for another day.